Okay, so this worksheet, we're going to look at a little bit of review and some notes on factoring. So we're going to do quite a few of the problems. We might break this into a couple of videos, but for the most part, we need to remember a lot of this stuff for the next math classes and for this class. So when we're talking a greatest common factor, which is a GCF, we're saying basically what can we divide out of every term? What's going to happen is our answer is going to have their GCF, so what we could divide out, and then the rest of it will be a polynomial, which will have the same number of terms as we started with. So what I'm thinking about this, I'm looking at the terms themselves. So I have a 28m and a negative 12. So I'm looking for what number will go into both 28 and 12. And if they have any letters in common, I want the lowest exponent of them. I want to basically be able to take out as much as possible without taking too much. All right, so if I know 28 and 12, I could list the factors if I needed to, but I know that 4 goes into both of these. So I could divide by 4, divide by 4. Then the GCF is this 4 that is underneath that I'm dividing out. So I write my answer is 4. Then I have my parentheses because it's going to be multiplied. And 28 divided by 4 is 7. I still have the m. And negative 12 divided by 4 is negative 3. Close my parentheses, and I just make sure that inside those parentheses, there's nothing else I can pull out. And then that would be my answer. Let's do one with the exponents, and I'll leave the third one for practice, and I will put the answer key up as I can. So when I'm looking at this, I have, if I need, I can think of, there is a coefficient of 1 here. So I'm looking at x to the 6th, or 1x to the 6th times y, plus 5x to the 3rd times y. Now I'm looking at what can I divide out of each one of them. They do have x's and y's for both of them, so I do know there's something I can take out. I look at the coefficients, so the 1 and the 5. The only number that goes into both of those is a 1. Since it's the first thing that we have, we can ignore it. It's that hidden 1 that we always have for a coefficient if there isn't one showing. And then I'm looking at my letters, and they both have x's. And this first term has 6 of them because it's x to the 6th just means you have 6 x's all multiplied together. X to the 3rd means 3 of them. I can only take 3 out of both of them. Otherwise, I'd go into negative numbers. So I'm going to take 3 out of them. They both have a y. And they both have just one y. So there's the exponent is 1. That is going to be my GCF. So x to the 3rd y. I'm going to take it out of both of them. And then when I write my answer, I write my GCF, which is what I'm dividing out. So x to the 3rd, y. I'm going to start my parentheses because I have to say what is left when I've divided it out. X to the 3rd, x to the 6th. So there's 6 of them on top. There's 3 on the bottom. So I'm subtracting them. So 6 minus 3 is 3. So x to the 3rd. The y's actually cancel out because there's the same number on each term. So I can say x to the 3rd. And then looking at the next term, I have a 5 divided by, if I want, a 1. So that is a positive 5 because there's other stuff in front of it. X to the 3rd over x to the 3rd, they cancel out. There's the same number top and bottom. Y's over y's, they cancel out. There's the same number on the top and bottom. And that would be my final answer. So my final answer is x to the 3rd y times the quantity x to the 3rd plus 5. Now, leaving the third one for you guys. You can check your answers when you're done, or you can ask questions about that later. The next type of factoring that we do are the differences of squares. These are special case trinomials. It is just a formula that, for the most part, people like. So we do teach it kind of formulaically. So when I have a difference of squares, I have a perfect square. So something with an even exponent, coefficients would be your perfect squares. I do recommend knowing your perfect squares. You could put them in the box if you wanted to that. So like 1 squared is 1, 2 squared is 2 times 2, which is 4, 3 squared, 3 times 3 is 9. And then 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144. Most people should know through 12. I do recommend a few extra ones. So that's 12. 13 squared is 169. 14 squared is 196. And 15 squared is 225. You can memorize more. Up through 20 is useful. I do find through 15 is a little bit better than going through 12 squared. However, as long as you know most of them or can find them quickly, recognizing them will make factoring easier for you in general. So this problem, w squared minus 49, is the same thing as w squared minus 7 squared. You know that you do have both of them are perfect squares. Then we have the formula. So the formula is just what was squared plus what was squared at the back of the parentheses times what was squared minus what was squared in the back of the parentheses. So I have a w squared and a minus 7. I have to have the minus sign. If you don't have a minus sign, you cannot factor with the difference of squares. One of them has to be minus. Put it in the order so that that minus sign is in the middle. It will make your life easier. And then what we get to do is 2 sets of parentheses. One gets a plus, the first one generally. The second one gets a minus. It doesn't really matter which one gets the plus and which one gets the minus. However, if the second one has the minus, you might have more factoring to do, so I just like to have it at the end. All right, what was in the front is the w squared. So w squared, if I square root it or break it down to what times itself was w squared, I have a w and a w. And then what times itself was 49. That is 7 squared. So in the back of the parentheses will become a 7 and a 7. And if I wanted to check it, I could FOIL it back out and I would have w squared minus 7w plus 7w minus 49. Those middle terms would cancel out and I would be left with what I started with. For this, I'm going to leave both of them blank for you guys to practice through because this is a formula. Be careful with it that when you're looking at that square, the minus one, that you don't still have a difference of 2 squares or things both being perfect squares. But check the answer key with this as well. Now, grouping. This is one of the ways that we can lead towards the factoring of trinomials, so it's kind of a good skill to have. And it's really just a special case of GCF. GCF, we can do out of however many terms we have. We should always check for that first because it makes numbers smaller. But when we're talking grouping, we have 4 terms. So I will put that here, 4 terms. And remember, terms are those groups of letters and numbers that are separated by those pluses and minuses. So with grouping, we do 2 things at a time. I will be nice, and we will actually, I'm going to start with the hardest one, and then I'm going to leave the other 2 for you guys. So we're going to do 2 things at a time with a GCF. So those 2 and those 2. I'm leaving no space with it, so I'm looking at the first terms, and I'm saying, what can I pull out of 3k squared and a minus 9k? With 3 goes into both 3 and 9, so I'm going to take out a 3 from both of them. They both have a k. This one has a k squared, so there's 2 of them. This one just has a k, so I can only take that out. So for this first group, I'm going to take out a 3k, and I will be left with 3. The 3's canceled out. There's 2 k's on top, 1 on bottom, if I want to think of there's the exponent of 1. So it's 2 minus 1. Those cancel out. So I have k to the first, so just a k. I have a negative 9 divided by 3 gives me a negative 3, and then my k's cancel out. Now, the one thing that we didn't really mention in GCFs is if you have starting the lead coefficient, meaning the first coefficient, if it is negative, you probably want to divide that out because we do not like starting with negative numbers. I don't like negative numbers in general. They will cause me problems, but I do not like to start with a negative. So no matter what, if I have this minus 1k plus 3, I do want to take out a negative. So I'm thinking that first because it's starting with a negative number. I really want everything to really start with a positive, especially when we're talking standard form and that kind of stuff. And then I look at these terms. So I have a negative 1k and a positive 3. The only number that goes into both 1 and 3 is 1. They both don't have a k, but I need to take something out. So the only thing that does go into both of them is that 1, and this is the only time that I will use that 1 is when there's nothing else that goes in. So in this case, because it starts with a negative, I'm actually taking out a negative 1. So my GCF is -1. I'm going to put that right here, thinking for my negative, my second GCFs. And then I'm going to divide that -1 from each one of those terms above it. So -1k divided by -1. A negative divided by negative is positive. 1 divided by 1 is 1, and they're stuck with a k. So I could say 1k, but since I have the letter, I'm just going to put the k. All right, a positive 3 divided by a -1 is a negative, and 3 divided by 1 is 3. All right, so now I've gotten it from 4 terms to 3 terms because this whole group is set by multiplication, so it is actually just 1 term. I do notice that my parentheses match, so they can be my new GCF. This is 2 terms. I do have a new GCF, meaning those parentheses match, so I'm going to divide, and it's your call if you want to write this. This is k minus 3 can come out of these two, this one, and k minus 3 can come out of here. And I'm going to write it with my GCF just like I did. So I have k minus 3. And when I simplify it, this cancels with this, and I have a 3k. And this k minus 3 cancels with the k minus 3 on bottom, and I have a -1. And it doesn't matter which order those parentheses are. I could have a k minus 3 times k times 3k minus 1 like I have written, or I could have the 3k minus 1 times k minus 3. I could switch the order if I wanted, but I will keep it like here. I will box this answer because there's a little bit more mess. And then I want you to practice with the other two. Yet again, I will upload the answers with this. All right, so trinomials. There's a whole bunch of different ways to do trinomials. Ultimately, trinomials are going to be the opposite of multiplying binomials together. For the most part, it'll be the opposite of multiplying polynomials by each other's when we think about this. So a lot of teachers have a whole bunch of different ways. The main purpose of what we're going to do is we want the product of the first term and the last term. Those factors have to equal that middle term. They have to combine to get that middle term. Like I said, there's a bunch of ways to do this. We will do at least probably 2 of these when we're thinking about this. I didn't give a lot of great examples, but we're going to look with signs and stuff like that. So I will do number 1 and number 12, I think. Yeah, or number 10 and number 12. So I'm really thinking of multiplying the first term and the last term. First of all, make sure that your polynomial is in standard form. So the letters have to be counting down exponent-wise in order. So I have a y squared, a y, and no y's. So this is 2, 1, 0, counts down. If it skipped something or didn't count consistently, then you can't factor it. You might be able to still pull out a GCF, but that'd be about all you can do. Look and see if there is a GCF. So I have a 1, a 12, and a 36. All I can pull out of the numbers is a 1. And I look at the letters. I have a y, 2 y's, a y, and no y's, so I can't pull a y out of every single term. So there is no GCF to pull out of these, which means I'm going to be looking at the first term times the last term. So I usually do some work off to the side. I'm going to give myself a little bit of room just so that it doesn't get mixed up in there. I have y squared times 36, and it's a positive 36, so I get to say that. So I really have 36 y squared. Now I need the factors of that 36y squared. That y squared means I'm going to put a y in both of those parentheses, so I can kind of ignore the letter for right now. I'm really thinking of my factors of 36, and 36 is 1 and 36. I usually write all of them down. 2 and 18, 3 and 12, 4 and 9, and then 6 and 6. So what I have with my problem is I can rewrite it. I need to find the ones that add because this tells me they have to be the same sign. Which means they have to add. This tells me since they're the same sign, this is what sign they need to be. And I'm just writing combine to this sign. All right, so I have just adding, so I get to add. And thinking about this, and I need to get 12, and I know 6 plus 6 equals 12. And I can think of it as a whole bunch of ways of I can use a box saying I need to start with 36 y squared, and I need it to, so this is the multiplying to 36, and I need it to add to a positive 12. The way I'm going to get that is a 6 and a 6. All right, so the way I could do this is my parentheses can be, breaking down that y is y, and then plus 6 and plus 6. I could have also redone this as, I think I can change colors. Yeah, okay, so I'm going to try this green and hope that that is dark enough. And I'm going to change this to, this is y squared. Ooh, that is not that dark. Y squared. Plus, I can rewrite my equation. So this 12y is what I added together to get that. So it's y plus 6y plus 6y plus 36. And I could do my 4 terms grouping. Looking at those two, I can take out a y. And that gives me a y times y plus 6. Looking at these two, I can divide out a positive 6 because it's starting with a positive number. So plus 6 y plus 6, which gives me my parentheses are the same. So I have the y plus 6. And then I have what's left is that y plus 6. So I could divide by the y plus 6. So there's a whole bunch of different ways to get these. A lot of times, sometimes people will write all the factors of the first term and the factors of the second term and look what ones they get to play with that. We're going to look at 12 as well. I'm going to go back to my, oh, this is gray this time. I'll use black. To this, in which case I'm going to take, looking at my terms, there's nothing I can factor out. They don't have anything in common. I'm going to be adding my terms. That means that plus sign means I add them. I'm going to be adding and getting a negative number. So if I'm adding numbers to get a negative number, I'm going to need them both to be negative. So if I'm thinking of how I want to do this, I'm really got my 4x squared and my 7, which gets me 28x squared. Okay, I could write my factors here, which are 1 and 28, 2 and 14, 3 doesn't go in there, 4 and 7, 5 doesn't go in there, and 6 doesn't go in there, and I'm back to 7, so that's all of them. I do a lot of tricks with counting, making things stay in order, just so that I don't miss the factor, because generally the factor I need is the one that I don't have. I could rewrite it, but I'm going to do a little bit more with that, the x box. So we have 4x squared times 7 gets me 28x squared. And I need them to add to a negative 16. And I need to have, if I'm thinking about this, a negative 4 and a negative 7. That does not equal to negative 16, so that's the wrong choice. I need a negative 2 and a negative 14. Okay, so I need a negative 2 and a negative 14. So I could rewrite it as 4x squared minus 2x minus 14 plus 14x. Don't lose your x's. So this is going to be x and x. So if I want to rewrite it like that, get my two parentheses. So this I can take out a 2x. So this gives me 2x times 2, 2 goes into 4 twice, so that's 2x minus 2x, because a negative and a positive is negative. 2x divided by 2x is 1. I need to keep both those terms. In these parentheses, I'm going to take out the negative first because I'm starting with a negative. And between 14 and 7, 7 goes into both. Okay, so this is, I just didn't want to write that. So minus, the GCF is minus 7. And then negative divided by negative is positive. 14 divided by 7 is 2. And then there's the x. And then a positive 7 divided by negative 7 is a negative. 7 divided by 7 is 1. GCF has those together, so I have the parentheses match, 2x minus 1 and 2x minus 7. Okay, so that's one way to do it. We can also think of when I was making these parentheses, I know there's another way I can look at this. I can do a box method, which I can show you in another video. I will probably make a whole nother video of all the different ways to do trinomials. I kind of like the X way, but there's other ways that we can do with the X and finding your factors along with that. So there's no one right way to do this. I tend to unfoil things and go from there, but I will show you a few other ways of doing trinomials in another video. So try number 11 with your signs, working with that. And then the last type of factoring that we usually have that shows up in a lot of problems is the sum and difference of cubes. And this means that I have to have a perfect cube, meaning everything has to be something times itself 3 times. The exponents have to be multiples of 3. And then it follows a specific formula. So it's always going to be looking at your problem. Are there perfect cubes? Some of those you want to know are like 1 cubed, which is 1 times 1 times 1, which is 1. 2 cubed is 2 times 2 times 2, which is 8. 3 cubed is 27. 4 cubed is 64, so be careful. Both 1 and 64 are both perfect squares and perfect cubes. And 5 cubed is 125. Those are what most people know to start with. 6 cubed is useful. You can go up to 10, but start recognizing some of them will be helpful. So if I have n cubed plus 8, this is the same thing as n cubed plus 2 cubed. The way the perfect squares for perfect cubes go is we always start with what was cubed, so n. What symbol were we using? We were adding them. And then what else was cubed? So 2. That is always your first parenthesis. Your first parenthesis is going to be that binomial, excuse me. So 2 terms. What was cubed? Did you add or subtract? And what else was cubed? And then we use that parenthesis to get the rest of them. At least that's the way that I remember the formula. So I always take whatever the first thing was. I'm going to square it now. So this will be n squared. And now I multiply what's in those parentheses together and make it opposite. So n times positive 2 would be 2n. And instead of a positive, I need to do the opposite, which is a negative. And then the last thing I have to do is square that last term. And in this case, it's a positive 2 times positive 2, which is positive 4. And that's all the formula. If to write it on words is a lot more complex, but really it's just find out what was cubed, how it was combined, and then we can work from there. The other one that I want to do, and then just make sure none of the parentheses or anything that you can factor out anymore. Sometimes it's GCF, sometimes not. So if we look at 14, We have 125, which is a perfect cube. This is 5 cubed. And then I have a y cubed. Minus 27 is 3 cubed. So I do have everything is a perfect cube. All my exponents would be 3. They could have been 6s, that kind of stuff as well, but that's what I have. So my first parenthesis is what's cubed, so I have a 5y. This time I have a minus sign, and then I have a 3. So 5y minus 3, all of that, each part was cubed. And then I'm going to do the rest of it. So I need 5y times 5y, which is 25y squared. I need 5y times negative 3, which would be negative 15y. I need the opposite of it. So instead of a negative, it's going to be positive. And 15y. And then I need a negative 3 times negative 3, which is positive 9. And that's how it goes. So hopefully that helps you get started on this. This worksheet looks a little bit different than the one we gave in class, but let's see how you can do with that. And then I will have some extra practice. I'm not expecting perfection yet. There will be a lot more factoring practice.